two fundamental differences between the Adam and Eve of the Bible and the evolutionary interpretation of mitochondrial Eve and Y chromosome Adam. The first difference has to do with time, and the second has to do with population size. The Genesis account indicates Adam and Eve lived recently, just thousands of years ago, and that they were the only two people alive at the time of their creation. The evolutionary model claims they lived around 100,000 to 200,000 years ago and belonged to a hominin population of 10,000 individuals. But as you will see, it's not the genetic data that conflicts with the biblical account of Adam and Eve. The conflict comes from inferences about time and population size.
Evolutionary geneticists estimate that genetic Adam and Eve lived around 100,000 to 200,000 years ago using a method known as the molecular clock. The technique relies on the assumption that mutations accumulate in certain regions of the genome at a constant rate over deep time. Evolutionary scientists have to further assume that humans evolved from a chimp-like ancestor roughly 6 million years ago in order to calibrate the molecular clock. Both claims are problematic and have been called into question by the genetics community. Distinguished evolutionary geneticist David Reich of Harvard confesses in the publication Nature, "The fact that the clock is so uncertain is very problematic for us. It means that the dates we get out of genetics are really quite embarrassingly bad and uncertain." Scientists are now using a more straightforward approach to determine mutation rates that do not require ape-to-man evolutionary assumptions. It involves directly measuring mutation rates in the present, comparing parents and offspring, known as the pedigree method. When comparing DNA sequences between parents and children, the measured mutation rates are typically 10 to 20 times higher than those inferred based on assumptions of ape-to-man evolution. When the molecular clock is calibrated using the empirically measured mutation rates, both mitochondrial Eve and Y chromosome Adam lived just thousands of years ago. In discussing the age of mitochondrial Eve, evolutionary scientists in Trends in Genetics acknowledge this discrepancy. mtDNA datasets often exhibit anomalous patterns. One of these anomalies is the discrepancy between mtDNA mutation rates observed in evolutionary timescales, for example, in dating the divergence between two species and those measured within family pedigrees. If the high mutation rates seen in some human pedigrees were used to calculate the age of our most recent female common ancestor, she would have lived just 6,000 years ago, a date more consistent with biblical Eve than mitochondrial Eve.
There's a long-standing debate and argument in genetics, and that deals with the difference between what's called the phylogenetic mutation rate and the genealogical mutation rate. If you look at a family, you can count the differences between the people and you say, oh, they've had some mutations. And you can actually calculate a mutation rate over time in today's time, in known time. Right now, we know what the mutation rate is. But the evolutionary community doesn't like to use that rate because it's too fast. They use what's called the phylogenetic mutation rate. That is, they look at the difference between humans and chimpanzees, not the real rate, but the differences, and they say, oh, we've been separated for so many millions of years. And when I was an undergraduate, that difference was 3 million years. Now it's 6 million years, 6.5 million years. Some people are arguing for 13 million years because mathematically they're having a hard time dealing with this. Take the differences between humans and chimpanzees in some gene, like mitochondria, Y chromosome, or something like that. Divide it by the time that separates us, 6 million years. You get a very slow mutation rate. But if you look at the people alive today, count up the number of differences between them, and divide by the time since their ancestor, maybe their great-great-grandfather, something like that, and you're going to get a mutation rate much faster. When we use that rate, Adam and Eve fall into the biblical time frame. So when we use today's science, measurable science, laboratory stuff we know is true, Adam and Eve are biblical.
While the actual genetic data reveals a single mitochondrial Eve ancestor and a single Y chromosome ancestor, evolutionists have insisted they must have lived in a larger population. For this reason, they caution the general public not to mistake the evolutionary Adam and Eve with Adam and Eve of the Bible. Yet they acknowledge there can be no direct evidence for the larger population size of 10,000 because all other mitochondrial and Y chromosome lineages supposedly died off, removing all traces of their existence, leaving, as paleo expert Chris Stringer has said, just one lucky mother and one lucky father. In an attempt to explain what would otherwise be another remarkable biblical coincidence, proponents of the ape-to-man model invoke what is known as coalescent theory. This theory assumes that over many generations, it is inevitable that eventually only a single mitochondrial and Y chromosome lineage will remain.
Coalescence theory is based upon the assumption of random mating. So you need a single population and all the people have equal likelihood of intermarriage. That's never been the case. From an evolutionary point of view, humans and pre-humans have always been in tribes that are separated. So there's not random mating. In fact, if you look at the charts that show coalescence, all you have to do is say, okay, that's one subpopulation, but there's dozens or hundreds of other subpopulations, and those would be producing a different coalescence to a different Adam or a different Eve. Basically, the coalescence argument fails. So their rebuttal position is not scientifically valid, and it's relatively reckless.
Evolutionary scientists reasoned that if humanity started with just two people, it could not explain the total amount of human diversity we see today. For this reason, a population of 10,000 became a central tenet of the current model.
It's typically assumed that Adam and Eve would have had no genetic variance, no genetic diversity. However, there's no reason to assume they were created as nearly identical clones. If Adam and Eve were created with built-in diversity for traits such as skin color, all of the different-looking people groups could easily arise in a biblical time frame. There would be no reason to wait millions of years for the slow accumulation of mutations if the diversity was encoded in their genomes right from the beginning.
If Adam and Eve were heterozygous, as we would reasonably expect, extensive genetic diversity would quickly arise simply through sexual reproduction, which reshuffles pre-existing variation to produce different combinations of traits.
This idea that God creates an initial pair with differences between them and within them. We'll call that term, the technical term is heterozygosity. So this is an idea that has massive consequences in modern genetics and virtually all of our genetic discussions. It also provides a convenient explanation, a very plausible explanation for how you get all the ethno-linguistic differences that we see today. Humans are considered one species, and we can produce variety in a single generation. So if a dark-skinned Sudanese person marries a light-skinned Finnish individual, their children will be an intermediate skin tone and have features from both parents. And if you had a Australian Aborigine who marries a Han Chinese, and they had children, and so then the offspring of these two mixed marriages had children, they could produce a whole diversity of individuals. Why is that? Because people today still have heterozygosity. They have less heterozygosity than what I'm saying Adam and Eve had. In other words, Adam and Eve could have produced in their many children every version of human that we see today. Once you have an original pair, original population, an original set of 8 if we're talking about the flood, that has heterozygosity, you can explain people groups just like that.
A striking example of built-in genetic variation can be seen in the example of twins born from mid-brown parents. Mother Kylie Hodgson and father Remy Horder gave birth to twins Remy and Kian, who appeared racially different. The two-tone fraternal twins shared the same womb and were born a minute apart. What most people would typically see as racial differences arose in a single generation due to gene segregation. Just like people living today, one can reasonably expect Adam and Eve to have had a large pool of genetic variation built in to their genomes. Prior to modern genetics, Evolutionary scientists claim that there were fundamentally different races of humans that evolved in diverse parts of the world over a long period of time. This model was known as the multi-regional hypothesis. This perception changed with the advent of DNA sequencing, which revealed that all human beings are remarkably similar genetically. It is now well established among the scientific community that all people, regardless of their skin color or ethnicity, are 99.9% genetically identical. The so-called racial features that we tend to focus on are essentially only skin deep, reflecting trivial differences in our genetic material. Physical traits like eye shape and melanin production amount to a minuscule 0.012% difference in our DNA. This means that regardless of our cultural differences, genetically, we are all part of one big human family.
If you have designed organisms, created organisms, they would be designed and created so they have internal diversity. You don't have to wait for mutations. So the waiting time goes away. If you want adaptation without deep waiting time, then just design the organism with variants in it. Even a single organism has heterozygosity, and so there's lots of genetic diversity. Even in a single organism, two individuals have 4 chromosome sets, and they have the ability to basically accommodate every possible variant. So 2 people is enough to allow for vast amount of genetic diversity that could be used by natural selection, be used for adaptation to new environments, and you don't need deep dive to do that.